In this lesson, you will learn how to write the equation of a line in slope-intercept form from a graph. In slope-intercept form, m represents the slope and b represents the y-intercept. The first step is to find the y-intercept of the line. The y-intercept is the point where the line crosses the y-axis. In this example, it is 1, so b equals 1. The next step is to find the slope of the line. To do this, first, locate 2 points on the line with integer coordinates. You can use the y-intercept as one point and then locate another point. Let's use this point. Remember, the slope of a line is defined as rise over run. Rise is the vertical change between 2 points on a line, and run is the horizontal change. To find the rise, start at the left point and count how many units you move up to reach the level of the right point. We move up 3 units, right? So, the rise is 3. To find the run, start from where you left off and count how many units you move to the right to reach the right point. We move 4 units, right? So the run is 4. Therefore, m equals 3/4. Finally, substitute the values of m and b into the slope-intercept form. Replace m with 3/4 and b with 1. That's it. This is the equation of the line in slope-intercept form. Now, let's try an example with a negative slope. We will also convert the equation to standard form after writing it in slope-intercept form. First, find the y-intercept. It is the point where the line crosses the y-axis, so b equals -4, right? Next, find the slope using 2 points on the line with integer coordinates. Use the y-intercept as one point and then locate another point. Let's use this point. Slope is rise over run, right? To find the rise, start at the left point and move down 5 units to reach the level of the right point. Note that moving up gives a positive rise, and moving down gives a negative rise. Here, since we moved down 5 units, the rise is -5. To find the run, from where you left off, move to the right 2 units. So the run is 2. Place the negative sign in front of the fraction. This doesn't change the value of the slope because they are equivalent fractions. So m equals -5/2. Finally, substitute the values of m and b into the slope-intercept form. Replace m with -5/2 and b with -4. Remember, adding a negative is the same as subtracting a positive. This is the equation of the line in slope-intercept form. Now, to convert it to standard form, first eliminate the fraction by multiplying both sides of the equation by the denominator. On the left, we get 2y. On the right, distribute the 2. 2 times -5 over 2x is -5x as the 2's cancel. 2 times -4 is -8. Notice in standard form the variable terms are on the left. So next, move the x term to the left by adding 5x to both sides. On the left, you get 5x plus 2y. On the right, these cancel, leaving -8. And there you have it. Your equation is now in standard form. The next example is a bit challenging, so stay with me. In the previous examples, the line crosses the y-axis at an integer point. But in this example, it doesn't, right? This makes it hard to determine the exact value of the y-intercept directly from the graph. So how can we find the y-intercept in this case? Here, the first step is to find the slope. Locate 2 points on the line with integer coordinates. Let's use these 2 points. Now, start at the left point and move up 7 units. So the rise is 7, right? Then move to the right 2 units. So the run is 2. Therefore, m equals 7/2. The next step is to find the value of b using the slope and the coordinates of one of the points. You can use either -1, -5 or 1, 2. Because these points lie on the line, they satisfy the equation, which means we can substitute their values for x and y into the slope-intercept form. Let's use 1, 2, as both coordinates are positive, making it easier to work with. But using -1, -5 will also give the same answer. Now substitute the slope and the point into the slope-intercept form. Replace y with 2, m with 7/2, and x with 1. Now, solve for b. 7/2 times 1 is 7/2. Next, subtract 7/2 from both sides to isolate b. Alternatively, if you prefer to avoid subtracting fractions, you can first eliminate the fraction by multiplying both sides by 2. On the left, you get 4. On the right, distribute the 2. 2 times 7/2 is 7, as the 2's cancel. 2 times b is 2b. Now subtract 7 from both sides to isolate 2b. Then divide both sides by 2 to isolate b. Therefore, the value of b is -3/2. Finally, substitute the values of m and b into the slope-intercept form. Replace m with 7/2 and b with -3/2. Adding a negative is the same as subtracting a positive, right? That's it. This is the equation in slope-intercept form. Now, before we move on to horizontal and vertical lines, pause the video and try finding the equation of this line. Notice that the line passes through the origin. The origin is the point 0, 0. So the line crosses the y-axis at 0, right? Therefore, the y-intercept is 0. Next, find the slope using the origin and another point with integer coordinates. You can use this point. Now, find the rise and run. Starting at the left point, move down 3 units. Remember, moving down means a negative rise, so the rise is -3, right? Then, move to the right 1 unit. So, the run is 1. Therefore, the slope is -3/1, which simplifies to -3, right? Finally, substitute the values of m and b into the slope-intercept form. This simplifies to y equals -3x. In general, if a line passes through the origin, its equation is y equals mx, because the y-intercept is 0. Now, what if the line is horizontal? What do you think its slope and equation would be? Let's find out. Locate 2 points on the line with integer coordinates. Notice that as we move from the left point to the right point, there is no vertical movement. We don't move up or down at all, which means the rise is 0. However, we move to the right 3 units, so the run is 3. Therefore, the slope is 0/3, which simplifies to 0, right? Remember, the slope of any horizontal line is 0. Now, in slope-intercept form, if you substitute 0 for m, you find that y equals b. This means the equation of any horizontal line is y equals the y-intercept of the line. Here, the y-intercept is 2, right? Therefore, the equation is y equals 2. This means y is always 2 regardless of the value of x. Try these. Write the equations of these 2 horizontal lines. For the first line, the y-intercept is -3, right? So the equation is y equals -3. For the second line, the y-intercept is 1, right? So the equation is y equals 1. Now, what happens if the line is vertical? What would its slope and equation be? Locate 2 points on the line with integer coordinates. As we move from the bottom point to the top point, we move up 2 units, right? So the rise is 2. However, notice that we don't move left or right at all. So the run is 0. Since division by 0 is undefined, the slope is also undefined. Remember, the slope of any vertical line is undefined. Vertical lines cannot be written in slope-intercept form because there is no number we can substitute for m, as it is undefined. Instead, the equation is written as x equals the x-intercept of the line. The x-intercept is the point where the line crosses the x-axis. Here, it is 3. Therefore, the equation of the line is x equals 3. This means x is always 3, no matter the value of y. Note that vertical lines do not cross the y-axis, so they have no y-intercept. Try these. Write the equations of these 2 vertical lines. For the first line, the x-intercept is -2, so the equation is x equals -2. For the second line, the x-intercept is 4. So the equation is x equals 4. To learn how to find the equation of a line that is either parallel or perpendicular to a given line and passes through a given point, check the link in the description. Give it a thumbs up and consider subscribing.